It's a real privilege to be able to talk about biofuels. Not too many people seem to be very interested, but I think it's really a major concern. As you probably know, when biofuels were first put forward as a solution to climate change, everybody thought it was most people thought it was a great idea. Environmentalists, politicians, Europe would be self-sufficient in energy production. Someone took a little closer look to the calculations and figured out that actually Europe couldn't be self-sufficient in biofuels, so they recast the narrative and said, now we're going to make a global market, and the poor countries of the world have a new source of income with which they can meet their millennial development goals. Biofuels became a magnanimous gesture by Europe to the rest of the world to produce things to supply Europe's energy needs. Within 5 years of the EU's market for international biofuels was created, associated environmental collapse was noted around the world. Most apparent was the smoke from the Indonesian forests being destroyed. And the negative consequences for food prices led to global food riots around the world in 2008. In June 2015, that's just a few months ago, the Paris-based Scientific Committee for Problems of the Environment, SCOPE, published a document they called Bioenergy and Sustainability, Bridging the Gap, which is only described as a propaganda document. It's just astonishing. It claims to be a global consensus, and it says that you can circumvent the food versus fuel debate associated with second-generation biofuels by this magic new thing called third-generation biofuels. Third-generation biofuels are non-agricultural crops grown on non-agricultural land. And this land was found through the application of the most advanced GIS-based computer models to assess global land supplies. Now, I think it's really important when we're in the theory realm of globalized everything to ask where the numbers come from, to ask what the models are about. And so in this presentation, I'll try to zoom through a rather complex series of ideas. I've tried to put highlights on the slides, and so I hope we all don't get too mixed up. First, I think that it's really important that my bias is made clear. As far as I'm concerned, third-generation biofuels are the latest form of denial of the fact of a finite Earth and human dependence on a functioning ecosystem. So there's my bias. Theorized demand. That's energy demand. To figure out how much biofuels we need to produce, you can do some mathematics if you live in a world of simple numbers. You first say that biofuels reduction is equal to CO2 reduction, and that can be calculated by the percent of fossil fuels to be replaced by biofuels. That's a bureaucratic decision, arbitrary, and you multiply that times an estimated future demand for transportation and electricity supply that could be substituted for by biofuels. To do this, you have to assume that they have assumed that demand equals consumption, that consumption equals sales, that the sum of sales in a country is equal to national demand, and if you add up all the country's sales, you get global demand. Now, to make these models and calculations, you need sources of information at a more than national scale. And there are 3 agencies that have about as close to independent energy data as you can get. United Nations Statistics Division, Eurostat of the European Commission, and the Energy Information Administration of the US. All 3 submit questionnaires to canvass their member states or units every year with questionnaires, and then they use estimates to fill in data gaps or inconsistencies. So whatever bias comes from the country comes with the data, but at the level of collection, it's fairly neutral. There are other agencies that produce energy statistics, demand, supply, any kind of combinations you want. And they're all linked in one way or another to energy, the fuel industry. The World Energy Council, these are listed in chronological order of establishment. In 1923, the World Energy Council was set up by actually an interesting idealist, and he'd given up on politicians and thought that if they got the engineers and technicians together to discuss energy problems, they could find an equitable way to have energy for the world. And it's now become an industry spokes thing, and it talks about proven reserves and productions and estimates into the future. The Atomic Energy Agency is obviously a UN agency with nuclear power. OPEC represents the oil companies. OLADE is, I don't know how you pronounce that, is for Latin American countries, and the International Energy Agency has industry leaders as well as member countries. So they all have a tie directly or indirectly to suppliers of energy. Where am I? How'd it go? Okay. There are basically, when you make a model, and then you can vary it according to new information or new applications, you take a standard model and you just tweak it a little bit, so you get a series of models. That's called a family of models. They're all related because they go back to a main standard. So there are two energy demand model families. And I don't know how you pronounce MEDEE. Do they say MEDI? MEDI. It comes from two gentlemen in Grenoble, France. It began in the 1970s. After the oil crisis in 73, European governments wanted to know what was future demand going to be like and what would future supplies be like. It's very rational. How do we balance what we're going to have? So this family of models was created. ETSAP is an organization inside the International Energy Agency in Paris, and they started the Markov family, and that's perfect foresight energy optimization models. And that those, and then POLS is a relatively newer one that also comes from someone based in Grenoble, and it does projections of energy demand and supply. Now, all of these three models, I think it's worth noting, have some sort of a French base. Nothing against France, it's just interesting. They probably all know each other as well. All of these models assume that demand can only increase. They assume that no one in the world has enough energy. They assume it is possible to model future demand from the past and the present. And they assume that information exists to feed into these models to make a sensible outcome. Now, social scientists say that we are in new societies called network societies, and so they have social science network theory. And one of the things people look for in social science is the sources of power. And in networks are based upon connecting previously isolated people and things and organizations. So the power of a network comes in the power of exclusion and inclusion. Models are actually social constructions that are a series of choices about what to include and what to exclude. That gives models enormous power, whether the modelers know it or not. When they choose to include something and when they choose to exclude something, that is a very powerful set of decisions. So model makers and people who use them should be very careful to figure out what has been excluded and state it. Models all have biases because they're built by human beings who have to make decisions about exclusion and inclusion. You can't include everything in a model. So you assume things about conditions that should be in the model. The values and the perspectives of the modelers will unconsciously guide choices. If you particularly like one thing, that'll probably be in the model. And if you really don't like something, it'll probably not be in the model. And there are definitions of what is important, which also reflect values. So models are mathematical, but they're not objective. They're biased from the moment they're constructed. And the reason why I pointed out that those energy models all have sort of a French basis is they reflect the values and the worldview of that time and that place where they were constructed. Now, these models have more than a local and national use. They have been used by investors and planners in governments, but they have also been used at global levels. Now, one thing that's interesting about these models is that they're enormously homogeneous. They all are combinations of econometric and technology. Yes, and technology. And the major driver is economics, and the desired outcome is cost-effective growth. So if that's not your outcome, the model's not going to be very good for you. Now, the trouble with economic models is that if your modeled economy doesn't fit the way economies actually work, it's going to be a failure. And if the things you assume to be true change, the model will fail. Now, this happened in 2008 in the economic crisis. Prices changed, markets failed, and the World Energy Council has a document in which they say, well, we were shocked, we were astonished. I mean, things that are supposed to be certain and true didn't happen anymore. And they claim that they were confused for 3 years and then came up with, instead of making confident predictions about the future, they would come up with scenarios. And these include things called black swans and the unimaginable, like the Fukushima power plant. So these models, although when you read the stuff up till about 2010, they're very confident and they're very certain, and now you'll find scenarios. That's because the model failed. All right, all these models and predictions produce statistics, which are in all the literature. Close your eyes and put your finger on a piece of global literature and read it, and it's got funny numbers in it. So I think it's really important to remember what an average is. Averages are useful. You can't look at everything. You have to find a way of combining things. So you usually take a sample of something and use it to make as a reference to a larger group. And there are statistical rules about how to make those selections. Now, this is just 5 observations, series of observations that have the average value of 200. And you can see that only this purple line is represented by 200. The blue line goes like that, the yellow line goes like this, but they all are 200. Now, that's getting rid of variation, and that's important. If we want to make a general statement, we can't include all the variation, or we can't say anything. I mean, this is a room full of people. That's a general statement. We've got males and females, we've got blondes and brunettes, we've got people with glasses and people without, but we're all people. So we just eliminate the glasses, the hair color, and the gender, and then we can make a statement. All right? So that's what averaging does. It gets rid of the stuff that's really not so important. Average values are essential for databases of primary information, factors used in mathematical equations, running models, deriving synthetic databases, and coarse-scale databases and reports such as global conditions. Now, there's a gentleman named Reinert who's written a very interesting paper, and he argues that when you first start with this averaging, you're making an abstraction. There are how many people in this room? We don't care about the glasses and the hair color. But if you take that average and you put this thing together with something else, and then you start averaging, and then you average again, and you combine, and you average, and you combine, you pretty soon lose track of what was the original thing being described. The number itself becomes important, and the quantification is the significance of the number. At that point, you have simplified. You're no longer abstracting, it's simplification. That's the removal of context and the denial of the significance of difference. Borrowing from the vocabulary of nutrition, it could be argued that because they've been stripped by attributes initially intended to be described, averages of averages of averages of averages are empty or low density or low quality numbers. They don't have much meaning. Now let's think about global statistics. What are they? They're summary statistics. They're usually averages of averages of averages of averages. They're coarse descriptors. They're easily manipulated in models, and they have absolutely no information about specific entities, actions, or places. They're simply meant to be at this very high, simplified level. The reliability and accuracy of these numbers is incredibly dependent on the data sets from which they're derived. That's very important. When you see a number, you say, where does it come from? And you go down, down, down till you can find the real thing it's attached to. Now we'll switch to some soil databases. This is the paper map of the FAO World Soil Map. In the mid-century of the 19th century, the 20th century, the FAO decided it would be really neat to make a world soil map. And it's an amazing idea. There were all these scattered soil surveys done by different colonial powers with different systems and different nomenclatures, and they thought, let's try to pull them all together. It was a really neat exercise. And so they ended up making a map, and there were certain points where they had, after they argued about what we'd call this and what we'd call that, and they made a legend, and then they had these maps, and then they had to figure out how to fill the bits in the middle. The Africa map sheet was the first one published, 1977, and this shows the level of documentation. Now remember that Africa is 22% of the Earth's surface. It's very large. It's very diverse. There are snow-capped mountains, there are hot, hot deserts, there are swamps, all kinds of things. The dark color here represent the places where there was good soil survey work. That's 7% of the continent. This striped area is really not much at all. General information with local soil observations. This one is soil reconnaissance. So the scale, it's very coarse, very coarse. In the 1980s, there was lots of change in the world, ideas about what money should be done, what should be spent on, and soil survey was either reduced or outright eliminated as an activity. And so the data that FAO had, because that was the only organization that had the responsibility for world soil data, it became called legacy data because it was actually measured. The databases that supported the paper, what became the paper map, are still there and archived. But after that, they needed to completely make new maps, but they weren't allowed to do any soil survey. And the most brilliant example is SOTER, which is the, the World Soil and Terrain Database that the FAO came up with. This is the Soil Survey Department, imagine. It was launched in 1986 by UNEP, FAO, and ISRIC. And they were strictly prohibited from doing any new soil survey work, yet they were to fill the gaps in on the maps. So they came up with something called taxotransfers and pedometrics, where they do lots of mathematics, and they've got this piece of information, that piece of information, they put them together in some sort of mathematical manipulation to fill in the spot here. That's a simplified version of it. And from that, they constructed something called a virtual soil profile. They didn't dig a hole, they didn't take any measurements, they took bits and pieces from other places and imagined how it would fit together, and that became a virtual soil profile. And from this activity, they came up with digital products, like the World Soil Resources Map, a lot of fiction in that, and a soil map of Africa, and information at regional levels. And they provide soil and terrain resources on a global scale for models to simulate food production. So simulate food production. It's all fantasy numbers. There's no data, there's no measurement. FAO came up with digital soil mapping, which is a blend of the legacy data, the original measured stuff, pedometrics, which is this numerical techniques to describe and map soils, and the virtual soil map profiles, and they came up with the digital soil map of the world. Now, these are some data sources that people today can access when they want to find something about soils at a global level. The old paper map from the world, you can still find them in libraries that haven't burned all their papers. Glassod, it was a global assessment of soil degradation This was designed by a gentleman who believed that the administrators and bureaucrats and politicians of the world weren't aware enough of soil destruction, and so he decided to make a piece of propaganda that would alert people to the problem. So he sent out a survey questionnaire to 290 people he imagined to be experts, and he asked them to estimate the scope and reason for soil degradation in the place where they existed, and to please draw a sketch map. And that was then quantified and digitalized and became a very precise looking map. But it really is expert opinion. Terrastat is a database that was produced in 2000, and the tables were easily downloaded from the FAO until quite recently. And it is based on Glassode, so it's got the questionnaires. It also is derivations, estimations, and expert opinion. AEZ and GAEZ are models, but they each have their own databases inside them. And they are also based on derivations, estimations, and opinion. This is the Terrastat database in detail, and again, you can see there's not a great deal of measurement in there. The agroecological zones are GIS-based modeling framework that combined land evaluation methods, socioeconomic criteria, and others. And it was done in the 1980s to 1990s. In 2000, when digital databases became available, they made GAEZ. And this was updated, revised, and improved calculations on AEZ. Now you'll find that the FAO documents, if you read the fine text, almost all of them have either AEZ or GAEZ as their source of information on their soil databases. This comes from Terrastat, and I bring it up because it's been so influential. One of the tables in the Terrastat database talked about potential available land, and it came up with numbers, millions and billions of hectares, and then in this place and in that place, and it defined land unused for agriculture, but still suitable for rain-fed cultivation of any one of 21 reference crops. And then it became available land. And they found that 70% of the available land was in Central and South America and Africa. In reality, this was grazing land and the forest. Most of it was the Amazon and Congo rainforests that everybody believes are the lungs of the earth. This is supposed to be potentially available agricultural land. So if you ever see, and actually in that region, it's like half a hectare for a family. If you ever see potential arable land, that should be a flash in your mind that it's rubbish. The World Bank, FAO together put out a document in 2009 that was about commercial agriculture, but it again is cited in many other literatures out of context, in which they identified from the AEZ model something called the African Guinea Savanna Zone, and it's spelled with an H. Most places don't have an H on their savanna. As you can see, it's in 27 countries, bits and pieces, and part of Madagascar. It looks like a real place, but if anyone has ever been to Africa, you know that that is not a homogeneous area. The other interesting document is FAO's 2012 Towards Agriculture and Future, and it identifies spare land. It uses the 2011 version of the GAEZ model, and it excluded forests. They'd been so attacked for saying that the Amazon should be arable land that this time they excluded forests and protected land and land occupied by cities. And what they came up was the world's grasslands, and 13 countries contain 60% of the identified spare land. Now I want to look pretty quickly at what the actuality of this land, fantasy land, is. In the spare land, they have Brazil, which is the Cerrado. It's oxasols and ferrolytic soils. Their putzels are very difficult I'll get into them later, but they fix iron, they take an almost unlimited amount of lime, they have no phosphorus, they have huge amounts of aluminum. The U.S. Corn Belt, that where they identified, it's actually wetlands and sand dunes. The Russian Federation has severe cold and drought limitations. Argentina in the Caldanal, high salinity and drought, and it's being destroyed by cattle ranching right now. Australian rangeland, old soils and drought. Sudan happens to have war, and they don't make a distinction between North and South Sudan. China is chronically water short. Democratic Republic of Congo has unknown soils, but they use the SODER system of imaginary, virtual soil profiles, and so that's what I think they're going to farm on. But it's in the Katanga province, which is a mining area that's been a war zone for at least 20 years. Kazakhstan has exhausted soils. It's where the Russians had their big wheat program. It has drought problems, but also has radioactive soils naturally occurring. Angola has landmines from 30 years of war. That they've got the highest number of amputees in the world. Where are we? Canada. The part of Canada they identify is cold and droughty. And Mozambique also has landmines and floods, and Madagascar has drought and floods. That's just at a superficial level. This isn't really ideal land. I just want to look at a couple of them up close for this. The Brazilian Cerrado is next to the Amazon. It's about the size of Europe. It hasn't been studied, so where do they get the number of 5% of the world's flora? That's a bit funny, but it's an incredibly diverse place. The soils are amazingly complex. The biodiversity in the rhizosphere is fascinating, and it's tremendously under threat. It's where the Brazilian government is pushing to have biofuels extended. It's broad and flat. The structures are good, and basically you remake the soil by pouring in phenomenal amounts of nutrients. This is the U.S. And Canada region that was identified as possibly biofuels. It's a wetland of major international significance. It's a breeding ground for the ducks and waterfowl of North America and also migratory shorebirds. It looks like this, and you can see that the agriculture, this is just like corn and beans, probably stimulated by biofuels in the States, pushing into the region. And it's the grassland around the potholes, which is where the breeding areas. And as that's pushed back, that reduces the breeding area of birds. So maybe we don't need waterfowl. The Nebraska sandhills are another part of, they're further west from the potholes. And it's where buffalo used to range. And they have cows now. And the significance is very sandy. It's the largest sand dune area in the Western Hemisphere. What's significant is that because it drains so well, it's responsible for 39% of the recharge of the Ogallala Aquifer, which underlies the central Corn Belt of the United States. So you finish and it was the protection of the Ogallala Aquifer, which is why Obama was finally forced to stop the pipeline coming down from Canada. So that's a very important water source. Russian Federation does indeed have abandoned farmland, and it's for sale. And if you read descriptions of the Russian farmland, you'll find that more than 50% of it is called submarginal. It's limited not only by cold, but the depth of freezing of the soil. It has unpredictable alternations of freezing and thawing during the year, and it has lots of drought potential, and livestock have to be confined 7 months of the year. I bring that up because the third generation biofuels people believe that what you do is apply high-tech feedlot style cow production to release the rangeland so that it can be turned into high-tech biofuels production. That's the logic. So it's got to be intensive cows. So if you're going to have cows in a barn for 7 months of the year, what are they going to eat, and where's that going to be grown? The Cardinal in Argentina, This is a before and after shot. It was a grassland like this. At the turn of the 20th century, they started doing cattle breeding, intensive cattle breeding, and it's now being really destroyed. And there are places where it's bare ground. Soil scientists have studied it and said that part of it cannot be recovered. The soils also have, they're calcareous, they're salty, they have selenium. The water quality is below that for human consumption. Cattle have to be taught to acclimate in order to be able to drink it. So the idea of more intensified cows and agriculture is crazy there. This is just really quick, that scale does matter. This is the idea of what they have for the Cerrado, and some of it's actually still is going on. This is the big crops, and this is the idea of, this is the idea of grazing systems. Oh, it's, I see, it came up actively. Which you can see, it's calling for rotating cows on these pastures. And they don't mention anything about manure management. Now in North America, especially the United States, where they developed intensive feedlots, the manure and urine runoff pollution from these operations is serious. It's like a small city without a sewer system. And there are real crises when they make these big dams and then they burst and they just don't know what to do it. So this is very highly drained soils, very low water supply, and a recent review of the existing small growing feedlots found that nobody had any idea what to do with manure management. It's just completely not in their scope. This is the contrast in Vermont, USA, which is a mountainous state, small dairy farms. And there was a project by the University of Vermont about 6 years ago to work with the farmers and extension agents. They developed crops. They tested soybeans, canola, and sunflowers. They found sunflowers was the best to grow in terms of yield and harvest. They developed the equipment. They then developed a processor to turn the seed into biofuel, biodiesel, and it was extremely successful. They were able to become completely self-sufficient for their energy needs on the farm. They produced a feed for the livestock and bedding to be used in the barns, and saved a lot of money and got them off fossil fuels. So the contrast is this is integrating biofuel crops into an existing rotation at a scale that the production reflects the unit where it's grown. That small unit is taken off the fossil fuels, and the cumulative effect of lots of small places being taken off fossil fuels would probably be more significant than something like that, which is going to cause more problems. So that's a speedy tour. And this is a picture of night, and it's light. And the question I always ask is, why should the dark continent supply the light continent with more energy? Thank you.